I'm Morimoto Shinichiro, leader of the Environmental and Social Impact Assessment team. We take a slightly different approach from other teams as we aim to create a zero-emission society. We do not research the technology itself. What we research is technology's relationship with society. Let's say a new technology is invented. We look at how it will impact the environment and energy, and what effects it will have on society and the economy. A comprehensive assessment of these things indicates what effects new technology will have. We can then easily imagine how we can spread the technology into the future. We employ assessments and simulations to find pathways to a carbon-neutral society. In this video, we will show you 4 pieces of research.
The presenter is Ozawa Akito. He uses a tool called energy models to study scenarios that would enable Japan to achieve carbon neutrality.
The Markle and Times energy models I use are tools that simulate future energy systems. What combination of energies and technologies would decrease CO2 emissions while satisfying energy demand at the lowest cost? Energy models enable those calculations. We use the energy models to conduct simulations under various conditions and identify scenarios concerning the future adoption of technologies and energy consumption. I think of scenarios as maps we need to carry when we walk toward our future goal. Nobody knows what path a society will take in the future. The results change depending on the conditions you give to the model. However, if you prepare a map to the goal with various routes, you can find the best way to develop a strategy. And if something unexpected happens along the way, you can soon find an alternative route. To reach the goal of carbon neutrality, what action should we take? If our research is useful for the government and companies to make decisions about their energy strategies, that will be wonderful.
正確なのかどうなのかっていうところをちょっとディスカッションしたいので、私もだから一緒に論文を読むので、みんなでその一緒に読んで。
Next, we'll show you research for assessing specific technologies to achieve carbon neutrality. Our research team leader, Morimoto Shinichiro, studies how we should introduce carbon-neutral technology through process simulations and life cycle assessments.
There are various carbon recycling technologies available now. But it was not clear what technologies introduced under what conditions effectively reduce CO2 emissions. That is why we run detailed technology simulations on the process level and develop life cycle assessments as a tool for evaluation. Using these tools, we can easily simulate total cost and CO2 reductions for a technology's introduction under various conditions. This kind of assessment is necessary to reduce CO2. With this assessment technology, I want to contribute to scenarios that lead to carbon neutrality.
This is the Gamma calculation platform. Its official name is the Gigantic Analysis Platform using modeling and AI. A dedicated facility GZR set up does amazing work analyzing big data that we couldn't handle before. Honda Tomonori developed and uses Gamma.
The development of IoT devices generates various big data every day. But because big data is so huge, it takes considerable time to analyze. That is why Gamma was developed as a calculation platform specializing in analyzing IoT big data. Using Gamma completes in a few hours analysis that used to take weeks. I use Gamma to conduct research with data on household power consumption to develop new lifestyles that fit in a carbon-neutral society. In recent years, smart meters have given us a precise understanding of how people use power. However, the data is so huge that the companies collecting it cannot analyze it. Gamma can quickly analyze the big data and allows us to conduct more simulations than before. For example, when storage batteries become widespread, we can analyze how households consume power differently and what impact that will have on society. Furthermore, from those results, we can predict what technologies and systems we will need to create a carbon-neutral society. As these results build up, they form the basis for designing power interchange systems for a carbon-neutral society and discussing what kinds of power grid network we should have. Then, we can suggest lifestyles that save energy without sacrificing overall comfort.
This research team has an expert in economics. Shimada Hideki's expertise is in environmental economics. He researches social acceptance of CO2-reducing technologies.
Put simply, social acceptance is about the extent to which people understand and accept new technologies during the deployment process. The CO2-reducing technologies will be deployed while affecting our society in various ways. In this process, they can create expected and unexpected burdens. When designing policies to spread new technologies, we have to think about what burdens they will create, to what degree the burdens will affect our society, and how we should deal with them. To spread CO2-reducing technologies, we must also look at problems in society. I use field research and data science to establish methods for assessing social acceptance.
We've learned about different branches of research, ranging from Japan's future decades to household power consumption. Our findings are used to assess the technologies other teams develop and as indicators for how to spread them in society. Furthermore, we serve as a leader in contemplating GZR strategy. We will continue researching to produce scenarios for carbon neutrality.